Hi, I'm Kurtz, and this is Easy Access Math, and today we're going to review hypotenuse. The lesson on hypotenuse involves the right triangle, and in the right triangle you have two straight sides, which are the A and the B, and they're attached to this box, this right angle on the corner. Opposite that, and I'll draw that line with an arrow, is the hypotenuse. That's always the longest side. We call that C. Now, on an exam, that might be represented by X or N. It could be any letter. You could also be missing one of the two straight sides. Those are the legs. If you're missing the hypotenuse, as I will be with these three right triangles, I'm missing the longest side, the side opposite the right angle, then I do A squared plus B squared equals C squared. That's the Pythagorean theorem, but don't worry about the name, just remember how to use it. That's the adding up because C is always the largest side. That slanted side, the side opposite the right angle, is always the largest. That's the hypotenuse. If you're given C, there's no place to go but down. And then you would do C squared minus B squared equals A squared. You would subtract. It's the opposite if you're given this side. But on these three right triangles, we're going to add because we're missing the longest side, the hypotenuse. So let's take a look. We have on the first one this green triangle, 12 squared plus 5 squared equals, and the missing one is the C squared. So I square them out. I have 144 plus 25 equals 169. The final step, and don't forget this, is you take that answer and you square root it, since this would be C squared and we're looking for C. So you square root that answer, and I wrote down the perfect squares. This list of these numbers, they're very important for you to know. If you can, try to remember them and be comfortable with them, but if not, derive your own list. It's easy to do. You just multiply numbers by themselves. 1 times 1, 2 times 2, 3 times 3, 4 times 4. You can make your own list and keep the list going. I have the first 15 perfect square numbers. Now, if your answer is a perfect square, it comes down to a perfect number, as this one does right here. 169 is 13 times 13, so your answer is just 13. No square root around the 13. It's a perfect square, so it's just 13. The square root of 169 comes to 13. Now let's look at this second one, this blue triangle over here, and there I have 9 squared plus 3 squared equals C squared. 9 times 9 is 81. Plus 3 times 3 is 9, and that gives me 90. 90 is not on my list. 90 is not there. But now what I need to do is I have to square root it. Let me do that first. That's the final step, but not quite final. You always want to square root because it's C squared and we want C. So we square root that answer after you add them up. Then I'll look at the list and I'll see 90 is not there. It's not a perfect square. But you can simplify 90. And if you can simplify the square root of 90, you must do so. And you may want to take a look at our videos on simplifying radicals. So, to simplify the 90, I look at the list and I'll say, do any of those numbers go into 90? And I want the largest number that can go into 90. And that would be 9. 9 times 10 in this case. Now, to finish it off, the 9 comes out as its root outside, and that's 3. 9 comes out as its root. The 10 part stays in. Okay, so 3 comes out, not the 9. Be careful, you're taking out the root of the 9. The square root of 9 is 3. That comes out. The 10 cannot have a perfect square. It doesn't, so it stays in the square root. And so I have 3 radical 10 as my answer. Now let's take a look at this last one. Remember here I was able to have an answer that broke down to a perfect square number. You didn't even have to simplify. It was a perfect square. Here you had to simplify using the simplifying of radicals technique. Let's take a look at this last one. I have 5 squared plus 2 squared equals c squared. Remember, these are all adding because on all 3 of these right triangles I'm missing the longest side, the hypotenuse. So I have 5 squared plus 2 squared equals c squared, which gives me 25 plus 4 equals 29. Remember, my last step is I take that 29 and I put it in the radical. I square root it. Can I simplify the square root of 29? Do any of these numbers go into 29? And the answer to that is no. None of these numbers can go into 29, so my answer stays as the square root of 29. Be careful that you don't pick plain 29 as an answer. It's 29 with the radical symbol around it when you can't simplify. You just leave it in the radical. So it's 29 with the radical symbol around it. Now 29 is a prime number, but let's say I had a number like 21 and it was in the radical. Now 21 has multiples. It's not prime. 3 times 7 is 21. But it doesn't have any perfect squares as multiples. Its multiples are not on this list. So 21 as well would just be left in a radical. It cannot be simplified any further. Now, there are many other numbers like that, and when that happens, be sure that you just leave them in the radical, but always check to make sure that they cannot be broken down, that they cannot be simplified using perfect squares. And this is how you do hypotenuse, and when you get a perfect square number, when you need to simplify, and sometimes you can't simplify the radical, so it just stays.